Very good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the Engineering Mechanics subject, the subject code of ME25C02 for the regulation of 2025. Earlier, we have completed Unit 1 with 4 parts of video lectures. Today, we are going to start with Unit 2, Part 1 video lecture. We will see one by one the slides of that. Unit 2 is statics of rigid bodies. Already we have seen statics of particles, that is Unit 1. Unit 2 is statics of rigid bodies. This mostly we will see the moment of a force about a point and axis, Weygand's theorem, principle of transferability, reactions at supports, and equilibrium of rigid bodies in 2D dimensions as well as 3D dimensions we will see. Today in the first part we will see some basic concept of those things. Then in upcoming videos you will look onto the problems also. Now we will see this. This slide represents this moment of the force about a point and an axis. See in this slide one application diagram. One pipe wrench they are using to loosen one pipe. They are fixing with the pipe and they are giving one rotational motion. In this thing we can see the force is acting in that direction, right? F is acting towards facing that side. And D is the distance with respect to what the object you want to rotate it. That is the reference point. Now what will happen means moment about axis OO is nothing but MO equal to F into D. The moment is nothing but force into perpendicular distance only. Force into perpendicular distance. In that we are getting force into perpendicular distance. Magnitude of MO measures tendency of F to cause rotation of the body about an axis along MO. So this is the magnitude cause the force to measures the tendency of the force to cause the rotation. What force we are giving to give a rotation, that is important. Along the MO, that is moment, force into distance. Here also in the right hand side of the image you can see moment about OO is MO equal to, that is F R sine alpha, that is also given. MO equal to otherwise R into F, we can give that as F, some force into perpendicular distance about that point O. Sense of the moment may be determined by right angle rule. Now this is principle of transferability. Any force that has magnitude and direction as F is equivalent if it also has the same line of action and therefore produces the same moment. So that is one important consideration we have to look onto this. So see in this various forces are acting, right? Various forces are acting at various points, but it produces the same movement having a same line of action. That is important thing. Therefore it produces the same movement. We can see MO equal to R1 into F, which is equal to R2 into F equal to R3 into F. Then here also Weygand's theorem, that is principle of moments. Moment of the force about a point is equal to sum of the moments of the force components about the same point only. What we are going to take, the summation of all algebraic sum of all forces, moment of all forces about one particular point, which is equal to moment of the resultant force about the same point. That is the definition. Here we wrote like this: MO equal to R into F equal to R into F1 plus F2, which is equal to R into F1 plus R into F2. Then rectangular components of a moment. We can see here various components are acting in various coordinates. See x-axis, that is fxi, that is I cap along x axis, j along y, k along z. Now we are using the formula mo equal to r into f equal to fxi plus fyj plus fzk. This expression already we discussed in the unit 1. The same thing again we are discussing here. R equal to xi plus yj plus k zk. Mo equal to mxi plus myj plus mzk. In matrix form we can write like this: ijk x y z fx fy fz. Like that we are taking all the components and we are writing what is for R and what is for f. We combined all the I components here. And finally, you know the matrix multiplication you will get. If you are taking I means what will happen? Fz y minus s z fy. The same thing again plus z fx minus x fzj. Then plus x fy minus fxy. We will get the expression. Now this another one. This one is moment of force F about point B. Point B. Now where is our point B? Below the A we are having B. MB equal to what you have to do? That force into what force? That capital F where it is acting. You have to see there. The capital F into RAB, the perpendicular distance of that one. RAB. Now what you have to apply? What is RAB? RAB is nothing but we have to take the coordinates of x, y, z and subtract it. X2 minus x1, the same concept. Here we are using xa minus xb, then ya minus yb plus za minus zb. Then f equal to fxi fyj plus fzk. Then m already we wrote there in the previous slide. Mxi plus myj plus mzk. Then matrix from the same thing what I wrote in the last slide. Again the same procedure we have to follow. Iyk, ijk, xa minus xb, ya minus yb, za minus zb, fx, fy, fz. Now, moment mo of a force F applied at a point A about a point O. Mo equal to R into F. R into F. What is our R? Here one distance that is acting and the force is acting. The red color one is the force. Perpendicular distance is nothing but R. So it is R into F. Scalar moment MOL about an axis OL is the projection of the moment vector MO onto the axis. That is this concept. Onto the axis. That is MOL equal to lambda should be considered. That is MO should be written. What is our MX? Already we got in the previous session. Previous slide already we got this in the matrix form. We got MX, MY, MZ. Now, movement of the force about an arbitrary axis, that is MB equal to RAB into F. What is our MBL? That is nothing but lambda MB equal to lambda RAB into F. What is RAB? RA minus RB. So like that, we can consider what are the forces that will get cancelled means we can see RB minus RC and Fi will act in the same line of action. If it is the same line of action means we can't take the perpendicular distance. We can't take the perpendicular distance. Therefore, the term will become entirely zero. Now, this is this problem. Next one problem is that calculate the magnitude of the moment about the base point O of the 600 Newton force in different ways. Now we can see here one real-time application is given. 600 Newton is applied at an angle of 40 degree and having some measurement distance. It is given 2 meters and 4 meters. Now we can find the moment about point O. What is the moment about point O? Keep the fixed MO equal to that is the value, the D into F, that is force into distance. What is our D? D is nothing but the component of 40. Sorry. that is cos 40, then sin 40, cos 40 and sin 40. Then finally, after multiplying with 600, then only we are taking 600. Initially we are not taking 600, only we took the distance only. Then finally we are getting 2610 Newton meter. Then we located here the same diagram. Here we can, the right hand side, the component split up, it is given the various sin and cos. Then again the continuation, we can use this formula, solution 2. Again we are solving in different methods. The same problem, again fx we are finding separately, then fy we are separately we are finding, and multiplying with the distance directly, and you are getting the value. That is one solution. And another one is solution 3. This is 4 plus 2 tan 40 degree. This is also totally different method we are using. Third and fourth is almost similar method. If you are taking cot means automatically the distance 4 will go there. If you are taking tan means 2 tan we have to take it based on the triangular rule we are applying. Then solution 5 is the basic concept, MO equal to RAT of, that is 2j plus 4j into 600 cos 40 degree I minus sin 40 degree j. Finally you will get in minus. Minus sign means the vector, it is in negative z direction. So this is the reference link which I used to prepare this content. Kindly go through it. It will be useful for you. Thank you all students. Thank you for your kind attention. Kindly go through the videos. Kindly subscribe the channel, and kindly share your video to your friends. So we will meet in the upcoming videos. Thank you students.